This video shows the physical layout of a Cascade common source amplifier in Cadence Virtuoso. Consider the common source amplifier shown for the layout purpose with inputs Vin, Vbias and Vout. The width of PMOS is total width is 20 micro, finger width is 5 micro, number of fingers is 4. 4 multiplied by 5 micro, the total width is 20 micro. Similarly, the width of NMOS transistor is total width is 16 micro, made up of 4 fingers multiplied by each finger width of 4 micrometers. And the body type is detached since the body is grounded, so I have kept it at the bottom. Similarly for PMOS, the body type is detached and it has a top tap. Click OK. So it has a top tap and the NMOS is having a bottom tap. Check and save the design. Then go to Launch. Click on Layout Excel or GXL. Create new. Click OK. This is the layout view. Go to the options, display, set the minor spacing to 1, major spacing as 5, and for better resolution you make it as 0.005. Click OK. Once this is done, go to the connectivity, generate all from source. IO pin is metal 1 drawing, and minimum separation is 0.12, which is the width of the metal one. Keep it as in boundary. To see the inner design, press Shift F. These are the fingers of a NMOS transistor, which is made up of 4 fingers. 1, 2, 3, 4. 4 polysilicons are placed. Similarly, we have a PMOS, which the width is 20 micro and it is also made up of 4 fingers. Let me arrange this. To stretch this PR boundary, select this or press yes and stretch upwards. Now adjust this one as well. Move this nearer, press F to align these two cells or the designs of PMOS and NMOS. Select this first transistor or NMOS, press A, then it shows the midpoint. Click here and again you click on the second transistor midpoint. Now they are aligned. Just select the transistor again, press M to move or create a space between them. We have the input pins here, output pins, followed by VDD and ground. To make the required connections, go to the window, assistance, and click on navigator. In the navigator window, you have the cells on the left. Click on next. It shows the connections. We have a ground pin here which is located, followed by VDD pin at the top. This pin is placed here. We can place on the top, and V bias, V in and V out. We need to connect all this. I'll place these pins in the form of a schematic, the same as that of a schematic. VDD at the top, ground at the bottom, V bias, V in and V out. To do that, go to the place, pin placement, and you can directly click on this place as in schematic. Click here. Now the pins are changed. Select the VDD and click on horizontal rail. You can observe you have a metal rail here at the top. Similarly, select the ground, click on horizontal rail. Once this is done, just close the window. You can see that we have placed the VDD pin here and ground at the bottom. Now you need to route only the V bias, V in and V out. Let us complete V ground first. Select the V ground. It says that these are the things which we have to connect to the ground. To do that, go to the layer palette. Select metal 1. Press P for path. Just draw or connect over the body towards the ground. Similarly, you have this. Go to the midpoint. You can connect up to here or you can go straight down to the ground. Since it is a body, just press enter. Similarly, this line. Identical lines are shown in the same colors. Again, draw up to the body. Once the design is completed, you can see that ground is totally connected for this Now go to the VDD. VDD at the top. So it shows that these two layers has to be connected to the VDD. Zoom it and set the midpoint. Finish. You can see identical colors are there. This one, this, and these three has to be connected to the body. Enter, and mid one. Observe that we have completed two. That means ground is completed and VDD is completed for the layout view. Now go to the V bias. This is a pin which is connected to the gates. All the gates of these fingers are connected. So go to the layer palette, search for polysilicon here. Press P to connect all these polysilicon fingers. Connect all this. Now connect this to the V bias. Drag, then right click to change the VR to metal one. Can go up to here or just leave it. See that V bias pin is here located. You can just move. See here the V bias is completed. Similarly completed for V in for this transistor. So you need to connect all the polysilicons together to complete the V in. Select again polysilicon, press P, then connect all of this. So that it forms a single gate. Now connect to the pin V in. So drag it, right click, via up to metal one. You can extend, finally enter. Now move the pin called V in onto this metal. Select the pin called V in and place it here. Try to observe the navigator. V in is also completed. Now you have to route only the V out pin. V out has to be connected. It is shown in with the highlighting colors. Go to the metal one, press P. Routing of this is done. Next, similarly, this is connected to the NMOS. Now just make the final connection here. It is not properly connected. You can observe that it is not connected. There is a slight mismatch while performing the layout. So let me delete this. Draw it again. Press P. You can enter here. Again, if you want, you can draw from here also. Just enter. Finally, you connect this to, let me draw this, or combine these two together. And finally, you draw a metal layer to connect it at the center. Place the pin. You can see that all the connections are made. Once the connections are made, save the design and go to the Calibri, run drc lvs, and you can check layout versus schematic.